So now we need to learn a few more concepts today. One concept would be the concept of independence between the two events that we're talking about. We said that if there is a spot on the face, then based on that, we can see that whether that spot has arisen because of acne or a cancer or deficiency of vitamin C or vitamin D and so on and so forth. Now we are talking about this only because there is a correlation between these two events, and there is a dependence between these two events. So the spots on the face do not come randomly; they come because of something causing that, and therefore there is a dependence between the spot appearing on the face and the cause of that in the form of vitamin deficiency or an overexposure to sun being present. So Bayes' theorem can be applied only if that dependence is there, only because one thing is arising because of another. Only then the Bayes' theorem can be applied. But there could be certain situation where you are given the two sets of data which are actually not helping predict the other at all. So for example, if you say, if I have two sets of data where, and we will take some very wild, unrelated example, that we will take the same example, that appearance of spots on the face and how many matches the Indian cricket team has won in T20 in that year. Now I can get those two data, but we know that there is no cause-effect relationship at all. Both of them are completely independent, and the one does not really arise from the other. If the India wins more matches, neither the spots will go down nor the spots will come down. It has absolutely nothing to do. And when that kind of situation arises, we say that these two events are completely independent, and therefore the Bayes' theorem can't be used. In fact, when we say that Bayes' theorem can't be used, you don't have to do anything. The numbers or the probability itself will actually show that there is no correlation here. And in that case, what happens is that the probability of A and B becomes just a simple multiplication of probability of A multiplied by B. And if there is a dependence, then we have already seen that the combined or the joint probability will be defined like this. And if there is no correlation between the two events, then it will be defined like this. And this is happening because if there is no correlation, then probability of B given A is actually meaningless. Whether the A is given or not given, B will have its own life, isn't it? So this becomes nothing but the probability of B, because the probability of B does not get impacted by the existence of A or not. And therefore, this simply translates into this. So when we say that Bayes' theorem can't be applied, that also is not a fully true statement, because as long as you have this number, it will eventually equal to this number, and the same formula would still apply. But we must be aware of this concept that there can be two events which are completely independent of each other. There's no dependence between the two, and therefore, the conditional probability actually does not exist. And no, we should not be even thinking about that we will get a better result just because I have something like Bayes' theorem at our hand. So Bayes' theorem can be applied only if there is a dependence. Not that the formula will not work, but actually you will not get any better insight by applying Bayes' theorem if the two events are completely independent. Okay. Now we need to get introduced to some more concept. We have already talked about how we can use. Yeah. Another very important thing is the chain rule. That is, until now we have talked about two things. And then in the context of that problem given to us by the hospital or the clinic, we said that we could have much more information, not just the spots. I could have the blood test, I could have the result of an CT scan or MRI or many other results I may have. And then I have a series of events, and when I say event is spotting of symptom 1, symptom 2, symptom 3. So when I have series of these things, how do I apply? Can I really apply Bayes rule? The answer is yes. Not that we go into the details of this, but it is just to say that if we have talked about 3 elements. Until now, we have talked about 2 elements, A and B. The same thing can be extended to 3 or more. And the way that it works is what is explained here. And if you see the last one, it will look like this one. So if I have the probability of A and B and C, that can be derived like this. But I will not go into details of this because we don't really need to go into depth of the mathematics of it. Just it is sufficient to understand that if the Bayes theorem works on 2 elements, it will work on 3 and 4 and 5, because what is called the chain rule in the probability.